This is paper 2 from June 2023, calculator paper for higher, 80 marks, an hour and a half to do this, so we're just going to work through it. Question number 1, and this is calculator use. So we're going to work out the value of 25 minus root 43.87 all over 6 add 2.1 squared. Now the first thing you want to do is use your calculator and use that fraction button. So that's the first button you want to be pressing, and then we're going to type in just as it is. So fraction button on the numerator, 25 minus the square root of 43.87 all over 6 add 2.1 squared. Now hitting equals, that gives me 1.76527923. So I've typed it in exactly like that. Shouldn't look any different in your calculator. You can do the numerator and denominator separately, but it's easier, I think, just to type it all in one go. Lovely. Then it says work out the value of the reciprocal of 0.625. Now you do have your calculator, so I would probably, if you don't know what this is, type this in your calculator, 0.625, and typing that in your calculator tells you that it is 5/8. The reciprocal of 5/8 is inverting that fraction. So the reciprocal of 3/4 is 4/3. The reciprocal of 2/3 is 3/2. The reciprocal of 4 is 1/4, okay? So those are some examples of reciprocals. Therefore, in this case, the reciprocal of 5/8 is going to be 8/5. And we can just write it like that. It doesn't want it as a decimal, just says what is the reciprocal. So 8/5 is your solution for that one. Quite a tricky first question. Question number 2, good old faithful. Write 60 as the product of its prime factors. So we're going to start with 60 at the top. Two numbers that multiply together to give 60. Now you can choose whatever you like. It's not going to affect your answer. It's going to be the same no matter what. I'm just going to go for 6 and 10. If you get to a prime number, you're going to circle it. So remember, your prime numbers are 2, 3, 5, 7, 11, 13, and so on. So 6, that's 2 times 3, and they're both primes. So we're going to circle those. And 10 is 2 times 5, and they're both prime, so we're going to circle those. So altogether, my answer is 2 times 2 times 3 times 5. Sometimes on this question, it says give your answer in index form. If it did, you would have to write it as 2 squared times 3 times 5, but as it is, either of those would have got full marks, absolutely fine, because it didn't say that, so you were okay to give it in either way. Question number 3, there are 48 counters in a bag. There are only red and blue counters in the bag. The number of red to the number of blue is in the ratio 1:2. Now I like for ratio to draw them out with the little hangman lines, 1 part on the left, 2 parts on the right. Helen has to work out how many red counters are in the bag. She says there's 24 red in the bag because 1 is half of 2 and 24 is half of 48. Is Helen correct? You must give a reason for your answer. So she's looked at this and said, right, well, I need to divide it by 2. So I'm going to say no. She needed to divide into 3 parts, not 2. So she needed to divide into 3 parts, and then one of them would go here and 2 of them would go there. So actually we need to do 48 divided by 3, which is 16. And so it would be 16 on each of those little lines. So we know that the number of red counters is 16 and the number of blue is 32. Question number 4, and we can see that n, which is an integer, so a whole number we're told here, is between -2 and 5. Now it's greater than -2 or equal to and less than 5. So that means it could be -2, -1, 0, 1, 2, 3 or 4. It can't be 5 because it's not got that equal to on that one up there. So that's all of the solutions there. Write down the greatest possible value of n, so that's going to be 4. Part B, on the number line below, show the inequality -4 is less than or equal to m, which is less than 1. So m is greater than or equal to -4, but less than 1. So I'm going to put circles over those two values. If it's equal to, you can colour that circle in. And then we're going to just join them up with a line, so looking something like that. The 1 is not equal to it, can't actually equal that value. Now, I remember my year 11 teacher saying to me, there's a little man on the line with a pen, and if he can reach it to colour it in, he will do. And so he's reached that value and he's coloured it in because it's equal to. I know it's a bit silly, but that's just how I remember it. So there we go. That's what it needed to look like. And for part C, solve 2/5 g minus 4 is less than 6. So whenever we're solving equations, what we do to one side, we're going to do to the other. The first thing I'm going to do is add 4 to both sides. So 2/5 g is less than 10. 2/5 g is less than 10. Okay, keep whatever symbol is here, keep it the same. Some people like to change it to an equals, but then they forget to change it back. So I would just keep it whatever it is. We've added 4 to get rid of the -4. Okay, now I'm going to times both sides by 5. So 2g is less than 50. And then I'm going to divide both sides by 2. So g is less than 25. And that whole thing has to go on the answer line. You can't just put 25 on the answer line because you need to show that it's less than 25. That is the solution. The less than is important. For 3 marks on that one. Question number 5. Here is a triangle and a rectangle. All measurements are in centimetres. The area of the triangle is 10 centimetres greater than the area of the rectangle. So this, add 10, gets you that one. Work out the value of x. So the area of the triangle, for the area of the triangle, we'll do base times height divided by 2. For the area of the rectangle, base times height. So I know that 8 times 6x divided by 2, that's that and that. 8 times 6x divided by 2 is equal to 5 lots of 4x minus 1, add an extra 10. Because we know that this area has to have 10 added to it in order to be this area. So I've done the area of this, 5 times 4x minus 1, add on the 10 equals the other area. Let's just sort that out now. So I've got 48x over 2 is 20x minus 5, because I'm doing this times this and this times this, add 10, which becomes 24x is 20x, add 5, because I'm at minus 5, and I'm adding 10, which brings me up to positive 5. What am I now going to do to both sides? Well, let's take 20x away from both sides. So 4x equals 5, and then we can divide by 4. So dividing this side by 4 and dividing this side by 4, x is 5 over 4. But remember, again, we've got that calculator. So x is 1.25 for that one. That's all we had to do. Work out the value of x. We've worked out the value of x, and that's it for 4 marks. So 1.25 is your answer for that one. Question number 6. Last year, a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. The weight of paper to the weight of glass was in the ratio 12:7. Calculate the weight of glass the family recycled. So first thing we want to do is work out 57% of 800. Now you absolutely can do 50%, 5%, 1%, 1%, add it together. But the easiest way to do that, given that we've got a calculator, is to do 0.57 times 800 in my calculator. That is going to get me 57% of 800. So 0.57 times 800 is 456, just using my calculator there. Now we've got to take that 456 kilograms, that is paper and glass. So now I want to share it in the ratio 12:7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. All together, I'm going to take that 456 and divide it. How many piles have I got there all together? It's 19. So 12 add 7, I've got 19 little piles. So 456 divided by 19 tells me that I've got 24 on each of those little lines. Now I could write them all in. I'm probably not going to, no, I've committed now, so I'll do it. 24 on each of those little lines. And that tells you how much is going to be paper and how much is going to be glass. So on the left-hand side, we've got 12 lots of 24. And 12 lots of 24 is going to be 288 kilograms of paper. And on the right-hand side, I've got 7 lots of 24. And 7 lots of 24 is going to be 168 kilograms. And that's your glass. So what did they ask me? They asked calculate the weight of glass, the family recycled. That's going to be 168 kilograms for that one. Question number 7. A number D is rounded to 1 decimal place. The result is 12.7. Complete the error interval for D. Rounding to 1 decimal place is the same, rounding to 1 dp, is the same as rounding to the nearest 0.1. Rounding to 1 decimal place is the same as rounding to the nearest 0.1. Now, if you're rounding to the nearest 10, you would go 5 above and 5 below, and that would tell you the maximum and the minimum. If you were rounding to the nearest 100, you'd go 50 above and 50 below, and that would tell you the biggest and the smallest. If you're rounding to the nearest 0.1, half of that is 0.05 and 0.05. So we're going to go 0.05 above, which is going to be 12.75, and 0.05 below, which is 12.65. So half what you're rounding to. If you were rounding to the nearest 1 whole, you do 0.5 above and 0.5 below. So those are your answers. It cannot actually equal that top value. If it did, it would round up, and that's why you don't get the equal to on that top one. You just get the equal to on the lower one. Question number 8. Tamsin buys a house with a value of 150,000. The value of Tamsin's house increases by 4% each year. Rachel buys a house with a value of 160,000. The value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house has the greater value? You must show how you get your answer. So this is compound interest. For Tamsin, we've got 150,000, and we're timesing that by 1.04 to the power of 2. We want 104%, and as a decimal, that's 1.04. So we times it by 1.04 for the first year, and then we times it by 1.04 again. So that's the same as squaring it. This is the number of years up here as the power. So typing that in my calculator, 150,000 times 1.04 to the power of 2 is going to be 162,240. So that's Tamsin's house after 2 years. For Rachel, her house is 160,000 times. Now, if you want 101.5%, that is 1.015 as a decimal. So we're going to times by 1.015 again to the power of 2, because we're just doing it for 2 years. So 160,000 times 1.015 to the power of 2, and that is 164,836. Now it says at the end of the 2 years, whose house has the greater value? You must show how you get your answer. So we're going to say Rachel's house has the greater value after 2 years. You could just put Rachel, that would be absolutely fine. Fabulous. Question number 9. The cumulative frequency table gives information about the ages of 80 people working for a company. A couple of things to note is that they've already done the cumulative frequency for you. So notice that the categories go from 20 to 30, 20 to 40, 20 to 50, 20 to 60, and 20 to 70. So they've already done that adding up process for you, okay? So you don't need to do the adding up. Sometimes you have to do it, sometimes they've done it for you. On the grid opposite, draw a cumulative frequency graph for this information. So remember, when we do cumulative frequency, we are plotting at the top of the category. So we're going to go across to 30 and up to 20. So looking at that grid, across to 30, up to 20. So your first point is there. Across to 40 and up to 48. So that's going to go there. Always check what you're going up in. This is going up in 1, so we're okay. Across to 50 and up to 64. So that's going to go there. Across to 60 and up to 75, which is there. And across to 70 and up to 80, which is there. You're then joining that up with a nice smooth curve. You can go to the origin on this one. Don't go to the origin on a frequency polygon. There we go. Nice smooth S-curve going to the origin. So that's that. We've done 2 marks there. Use your graph to find an estimate for the median. Now we know there were 80 people. So the median would be the 40th person. Technically the 40, between the 40th and the 41st, but because it's a graph, we just go across at the 40th. So we're then going to get our ruler and we're going to read across at 40, hit the graph, and then go down, and that would be our median. So the median there would be at 37 years of age. So my median, 37. 3 marks for that one. Question number 10. A biased dice is thrown 60 times. The table shows information about the number that the dice lands on each time. So we've got a number on the dice, 1, 2, 3, 4, 5, 6, and the frequency, so how many times it landed on each of those numbers, 12, 7, 8, 9, 9, 15. Gethin throws the dice twice. Work out an estimate for the probability that the dice will land on a 6 both times. So the probability of landing on a 6 is equal to 15 out of how many times we threw it all together, which is 60. So 15 out of 60. And if we want it to land on a 6 and then a 6 again, we're going to multiply that by itself. So 15 out of 60 times 15 out of 60, which is a quarter times a quarter, or you can type it in your calculator like that. Either way, you're going to get 1 out of 16 for that answer. Or you might have got 225 out of 3,600. Either of those answers would be absolutely fine. That or that for 3 marks there. Sally's going to throw the same dice n times and record the number it lands on each time. She'll use her results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? If it's more reliable, she must be rolling the dice more than 60 times. So n must be greater than 60. Question number 11, use algebra to solve the simultaneous equations. So these are linear. So what we're going to do to solve these simultaneous equations is I like to make the numbers in front of the y the same. The first number in the 4 times table and the 6 times table is going to be 12. So I'm going to make both of these 12. I'm going to times everything on the top by 2 and everything on the bottom by 3 to make them both 12. So that's going to be 4x add 12y equals 10 and 9x minus 12y equals minus 36. And now we've made these the same. Now you're going to add if they're different and same signs subtract. Add if different, same signs subtract. So because one is an add and one is a takeaway, if I want to cancel those out, I'm going to turn it into a big sum. And we're going to add if they're different. So we're going to add these, and that's going to cancel them out. We want to get rid of those y's. So 4x add 9x is 13x, and 10 add minus 36 is minus 26. And when we've added these, they've cancelled each other out, so that term is gone. Okay, so 13x is minus 26. Divide both sides by 13. And x equals minus 2. Once you know that x is minus 2, you're going to take that and put it back into either of these top equations. I'm just going to use the top one. So 2x add 6y is 5, but we now know that x is minus 2. So 2 lots of minus 2, add 6y is 5, minus 4, add 6y is 5, add 4 to both sides, and so 6y is 9, and if we divide that by 6, then y is 3 over 2, or 9 over 6, so 1.5. There we go, so x is minus 2, and y is 1.5 for 4 marks. Question number 12. The points A, B, C and D lie on a circle centre O. A, B, C, D is a rectangle. A to B is 8 and B to C is 10, as we can see on the picture. Work out the circumference of the circle. Give your answer correct to 3 significant figures. So we know that for the circumference is pi times diameter, or 2 pi r if you'd rather, but pi times diameter. So we need to work out what the diameter is. Now the diameter, the easiest way to work that out is to go like this. This is the diameter of the circle. And so if I look at this, I've got a right angled triangle and I'm going to use Pythagoras. So I'm going to say that 8 squared add 10 squared, which is 64 add 100. So 164, and then we need to square root that answer. So the square root of 164, type that in your calculator, and that is 2 root 41, or 12.80624847, and so on. That is the diameter of the circle. If I then want to know what the circumference of a circle is, I can use my formula. Circumference is pi times diameter. So I'm going to do pi times that answer, times that by pi, and that equals 40.23201,613, but it says round it to 3 significant figures. That's your first significant figure, that's your second, that's your third. The next number rounds down, so 40.2 would be your answer for the circumference of that circle. Question number 13. ABC is a triangle. Calculate the size of angle BAC. Now, this triangle does not have a right angle. If a triangle has a right angle, then you can use SOHCAHTOA or you can use Pythagoras. And we can use neither of those because it doesn't have a right angle, this triangle. So that tells me that it's either going to be cosine rule or sine rule. Okay, so do we have a pair? What are we trying to work out? So the size of angle BAC, they're asking you for this angle here. And I do have a pair. So I know this 70 degrees and I know this side, and they are a pair. They can go together. So because I've got a pair, I'm going to use the sine rule. So remember, the sine rule is either A over sine A equals B over sine B, if you want a side, but if you want an angle, it's going to be sine A over A equals sine B over B. So I'm actually going to use it this way up. Now, here is something that we haven't considered. I've got this pairing in blue, which is fine, but this side over here goes with this angle here. But that's okay. What we're going to do is we're going to work out this angle, and then we're going to take it away from 180, and that will enable us to get that one. So let's do sine 70 over 18 equals sine y over 15. And then I'm going to times both sides by 15 to try and work out what that y is. So sine 70 over 18 times by 15. And that's going to be sine y, but don't forget that we are going to need to do sine to the minus 1 of that answer. So typing that in my calculator, I get let's do sine y equals 0.783077. So we just need to do sine to the minus 1 of that answer to actually get the angle. So shift sine in your calculator, and that's going to be 51.5431 degrees. Lovely. So that's that angle there. That angle there is 51.543. And then therefore, if you want this one, we're going to add together this angle and take it away from 180. So 70 add 51.543 is 121.543189, and then we're going to take that away. 180 minus 121.543 is 58.4568, and we're rounding it to one decimal place, so that's going to be 58.5 degrees for that missing angle there. 58.5 degrees. Let's pop that on the answer line. There we go, 4 marks for that one. Question number 14. Show that x squared minus x minus 6 over 2x squared minus 5x minus 3 can be written in the form ax plus b over cx add d, where a, b, c and d are integers, so whole numbers. To simplify this, we need to factorise. So to factorise, we want to put it into brackets. Now this is going to be 2 brackets on the top and 2 brackets on the bottom. Do whichever one you find easiest, because there is going to be a matching bracket here because we are going to be able to cancel it down. So firstly, I'm thinking of 2 numbers, that times to make minus 6 and add to make minus 1. So that's either going to be 1 times 6 or 2 times 3. So it's going to have to be 2 times 3 to make that minus 1. So I'm going to put x add 2, x minus 3 on the numerator. And then for the denominator, I know it's going to be 2x and x, because it needs to multiply to make 2x squared. And I know to times to make minus 3, it has to be 1 and 3. Now, if it's going to be 1 and 3, it's going to have to be this way round, because I need a matching bracket, and that wouldn't happen otherwise. So I know this one's going to be minus. So I've got 2x squared minus 6x, that's going to be add 1x, minus 3. So I've just trial and errored that. You can split the middle term. There are lots of different ways of doing that. And then we need to look for a common factor. Both the numerator and the denominator of this fraction is divisible by x minus 3. So I'm going to divide the numerator by x minus 3 and divide the denominator by x minus 3. So you're left with x add 2 over 2x add 1. I can divide the top, divide the bottom, and I'm just left with that. So that would be my answer. And that's exactly what they've got. Now you might think, oh, I've done it wrong because I've got no number here where A is. But remember that A is just 1. We just don't write it in. So A is 1, B is 2, C is 2, and D is 1. So that would be your final answer for 3 marks. Question number 15. Here are the first 4 terms of a quadratic sequence. Find an expression in terms of n for the nth term. So I've got 3, 9, 17, 27, just writing it a bit bigger. Now the first difference, that's gone up by 6, that's gone up by 8, and that's gone up by 10. Now for a quadratic nth term, that first difference is not going to be the same. So then we're going to do the second difference, the difference of the difference, add 2. Whatever that number is, you're going to half it. So we're going to take that number and divide it by 2, which is 1. So therefore I know it's 1n squared. Now the sequence 1n squared would be 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, and 4 squared, which is 16. Underneath we need to say how much more do we need. So I've got 1, but I want 3, so I need an extra 2. I've got 4, but I want 9, so I need an extra 5. I've got 9, but I want 17, so I need an extra 8. And I've got 16, but I want 27, so I need an extra 11. What is the nth term for this sequence? So this is the 3 times table, but each number is 1 smaller. So that's 3n minus 1 is the nth term for that bit. And then we can see that if we put those together, 1 and 2 makes 3, 4 and 5 makes 9, 9 and 8 makes 17, 16 and 11 makes 27. So therefore these two nth terms together is my answer. So I need n squared add 3n minus 1 for 3 marks. I've just added those together. That's going to give me the sequence that I want. Question number 16, and we have a histogram. The histogram gives information about the numbers of hours some students used their phones last week. The histogram is incomplete. It says 28 students used their phone for between 30 and 40 hours. So we know that the area, remember with histograms, it's the area of the bar that is the frequency. So I know the area of that bar is 28. 24 students use their phone for between 40 and 60 hours. We haven't got that bar yet. This bar then we know has an area of 28. It's 10 wide from 30 to 40. Therefore, to have an area of 28, it must be 2.8 tall, because 10 times 2.8 is how you're going to get that area of 28. If you know that that's 2.8, you then know that this is 2, that this is 1, this is 3, and this is 4 up here. So then if I want to do 24 students use their phone for between 40 and 60 hours, I need the area of the bar. This is going to be 20 wide. So I'm going to do 20 times something to give an area of 24. So 24 divided by 20 is 1.2. So therefore I know that that bar is going to go up to 1.2, so that when I do base times height, that has an area of 24. Uses information to complete the histogram, so that's fine, we've done that. No student used their phone for more than 60 hours. Work out the total number of students. So we just need to work out the area of all the other bars. This bar here is 20 wide times, and this is 1.6 tall. So 20 times 1.6 is going to be 32 students in that category. And then for this bar here, we're 10 wide times by the height, which is 3.6. So that's going to be 36 students in that category. And then all we need to do is add that together. So you've got 32, add 36, add 28, add 24, and I am just going to type that in my calculator. Absolutely nothing wrong with using your calculator for that. 32, add 36, add 28, add 24. You might as well use it, and that is 120 students. 120 students in that survey, or that they asked in total. Fabulous. Question number 17. Show that the equation x to the power of 4 minus x squared minus 5 equals 0 can be written in the form x equals the fourth root of x squared over 5. Now, the fact that the last thing they did was the fourth root makes me think that they got that x to the power of 4 term on its own. So we can change this to be x to the power of 4 equals x squared add 5. I've added x squared to both sides, and I've added 5 to both sides. So we've got that, and then I'm going to do the fourth root. And that's all they want to see for, how many marks is that? 1 mark there. So rearranging it so that they've got that x on its own, and that's now turned into that. Part B, starting with x naught is 1.5, use the iteration formula, xn plus 1 is the fourth root of xn squared add 5 3 times to find an estimate. Now all this means, this looks really complicated, but all it means is to get to the next x, you need to do the fourth root of the x you're on now squared add 5. Now what you're going to do is take your calculator, and I want you to type in 1.5 and hit equals, and that's going to store it in your calculator. That's a good starting point. So 1.5, hit equals so that it's stored as the answer. So stored as the answer. There we go. And then all I'm going to do is I'm now going to type this in my calculator. So in my calculator, I'm typing the fourth root of my answer squared add 5, because then it will just take this 1.5, square it, add 5, do the fourth root, and then get me the next one. And then if I hit equals again, it'll get me the next one, and so on. So I'm going to do the fourth root in my calculator of the answer squared add 5, hitting equals. So x0 was 1.5, which means x1 is 1.6409090017. Hitting equals again will get you straight to x2, 1.665398,002, and hitting equals again is 1.669763,088. Write down all the numbers on your display. They told me to do it 3 times. So 1, 2, 3. There we go. And then I would write at least 5 decimal places. The mark scheme for this does just say write it all down. So writing all the numbers down on your calculator display. 1.669763,088 on the answer line. It does say you must have at least 1.6697 for the mark there. So make sure you've got a good number of decimal places for an iteration question. Okay, question number 18. Okay, it's given that 2a to 5c is in the ratio 6 to 25. So 2a to 5c is 6 to 25. Now, if I want to know what a to c is, what I'm going to do is I'm going to take this side and divide it by 2. And I'm going to take this side and divide it by 5. I should have done like that really, shouldn't I? So there we go. So dividing by 2, dividing by 5. So therefore we've got 3 to 5 as the ratio a to c. I'm now going to do a similar thing for the other one. 4b to 7c is 20 to 21. So if I just want to know what b to c is, I'm going to divide by 4 on this side, and I'm going to divide by 7 on this side. So that's going to be 5 to 3. Now, both of these ratios have c in common. So I've got c on this ratio and I've got c on this ratio. It would be helpful if those numbers were the same. So what I'm going to do is I'm going to make both of those 15, because 15 is the first number in the 3 times table and the 5 times table. So if I make this one 15, I've times by 5, so I also need to times the other one by 5, which is 25. With this one, I would need to times by 3, so I also need to times this one by 3, so that's 9 to 15. So I now know the ratio A to B to C can be written as 9, that's A, to 15, oh no, 15 is C, to 25, that's B. So I'm just using B is 25, C is 15, C is 15, and A is 9, like that. So A to B to C is 9 to 25 to 15. Now that we've got them all in equivalence, we can now write A plus B to B add C in those terms. So the first one was A plus B, so A plus B to B add C. So A plus B is 34 and B plus C is 40. Now both of those numbers are even, so we can divide both sides by 2, simplify it, and that's going to be 17 to 20. And that is what they told me to get. There we go, 17 to 20. So for 3 marks, that would be our final answer there. Question number 19. ABC is a right-angled triangle. A to B is 9.3, correct to the nearest millimetre. Now the nearest millimetre here is the same as the nearest 0.1 centimetres. So 9.3 has been rounded, and the biggest it could have been is 9.35, and the smallest it could have been is 9.25. Same with AC. It's 12.6 correct to the nearest millimetre, which is the same as saying the nearest 0.1 centimetre. So that's going to be 12.65 and 12.55. Calculate the lower bound for the size of the angle marked X. Now, X here, we're going to have the opposite, and we're going to have the hypotenuse. So that is going to be SO. And in your SO triangle, you're saying sine to the -1, opposite over hypotenuse. So it's going to be 9.3 whatever over that bottom value of the hypotenuse. Now, think about your sine graph. Sine is an S and cos is a cup. Now, because we are only looking less than 90, actually, as the ratio gets bigger, the angle does get bigger. So if we want the lower bound, we do want to make this as small as possible to get the smallest possible angle. So I do want to make this as small as possible, which means if I want the opposite over the hypotenuse to be as small as possible, I'm going to do the smallest possible opposite on the top and the biggest possible hypotenuse on the bottom. So it's going to be sine to the -1. The opposite, the smallest we can make that, is 9.25. And the hypotenuse, the biggest we can make that, is 12.65. And that's going to get us the smallest possible angle. You can always just try the other values if you're not sure which way round to do it. 9.25 over 12.65, you can always trial and error a little bit, but that gives you 46.989, and it's asked me to, oh no, that's just the lower bound, so let's just write, yeah, it wants at least that, so let's do 46.9892135.6 on the answer line for that. Anything from 46.98 to 47 was absolutely fine with correct working. Quite tricky, that one. Question number 20. ORT is a triangle. O to T is A, that's given there, and R to T is B. M is the point on OR such that O to M, M to R is in the ratio 2 to 3. So that's out of 5. So we know it's 2/5 and 3/5 of that line. Express M to T in terms of A and B. Give your answer in its simplest form. So if I want to go from M to T, I'm going to go down here and along here instead of going like that through the middle. Okay, so first thing I need, I can get from here to here, that's A, but I need to go down this bit, and this bit is 2/5 of R to O. So we're going to start by getting R to O. Now R to O, I'm going to go round like this. So R to O, we're going with that B arrow, and we're going against that A arrow, so that's going to be -A. So if R to O is that, M to O is 2/5 of that. So M to O is 2/5 B minus 2/5 A. If I then want to go from M to T is going to be 2/5 B minus 2/5 A, but then we need to go along here, so we're going to add an extra 1 whole A. Now you might want to write that as 5/5. So you might want to say that's 5/5 of A, just because you might find that easier to add on. So M to T, which is what they want, is 2/5 B, and then I've got minus 2/5 A, add 5/5 A, which is going to get me up to positive 3/5 A, and you can write that either way round. 2/5 B, add 3/5 A would be your final answer. Yeah, I might just write it the other way round on the answer line actually. 3/5 A, add 2/5 B. There we go, for 4 marks. Question number 21. Here is the graph of y equals f of x. On the grid below, draw the graph of y equals f of x minus 4. So this moves the graph down 4. We need to draw that shape, but 4 lower. So instead of it being here, which is where it is at the minute, that's f of x, we need to move it down 4. So 1, 2, 3, 4, and it's going to go there instead, f of x minus 4. I don't need the original one, so that's fine, that's where it's going to end up. And then for this one, we've got y equals f of minus x. Now this is inside the brackets. Anything inside the brackets moves left to right or changes the x direction, affects the x direction. So if at the minute it's here, this is where f of x is at the minute, then f of minus x is going to be a reflection across the y-axis. So this would be f of minus x here, and again we don't need that original, that's just me showing you. So there we go, that would be where your graph has ended up for f of minus x. Question number 22. There are only blue pens and red pens in a box. The number of blue pens is 4 times the number of red pens. So therefore the ratio of blue to red is in the ratio 4 to 1. Rita takes at random 1 pen from the box. She records the colour of the pen and then replaces it in the box. Rita does this n times where n is greater than or equal to 2. write down an expression in terms of n for the probability that Rita gets a blue pen at least once and a red pen at least once. So we want a probability tree here, and we've got blue and we've got red. So she's going to take a pen out of the box, she records it and puts it back in the box, and then she's going to do it again, but she's going to do it n times. So let's see if we can spot a pattern here. We've got blue, red, and then let's go again, because this might just be easier to spot a pattern. Blue, red, blue, red, blue, red, blue, red. So what we're saying here is that we want her to get at least a blue pen and at least a red pen. So we want her to get at least one of each colour. So the only routes we don't want are these routes where she gets all blue pens, or this route down here where she gets all red pens, but we want everything in between. Now we know that probability adds up to 1. I also know that the probability of blue is 4 out of 5, and we're putting that pen back, we're replacing it, so that's going to stay 4 out of 5, and that's going to stay 4 out of 5. Red is 1 out of 5, and 1 out of 5, and 1 out of 5. So however many times she does it, which we know is n, it's going to be 4/5 times 4/5 times 4/5. So that's going to be to the power of n. So therefore, my answer here is going to be, so the probability of all blue is 4 over 5 to the power of n. The probability of all red is 1 over 5 to the power of n. And so the probability of the rest is going to be 1 take away 4/5 n, and also take away 1 over 5 n. But that is an exceptionally difficult question on GCSE. I really do think that is very, very challenging. So yeah, well done. If that makes any sense, well done, because that is a very, very tricky one. Okay, question number 23. Here are 3 similar triangles, ABG, ACF, and ADE. Now, I think with these questions, it's easier to draw them separately. So let's say we've got the small triangle like this, then we've got the medium triangle like this, and then we've got the big triangle like this. And they're similar triangles, so they're just enlargements of each other. Now it says A to B, B to C, and C to D are in the ratio 1 to 2 to 3. So this triangle has a side length of 1, this triangle has a side length of 3, and this triangle has a side length of 6. Okay, so that's going to come in helpful for our linear scale factors. Show that the area of ABG, which is the top triangular bit, to the area of BCFG, which is the middle trapezium bit, to the area of CDEF, which is the bottom trapezium bit, is in the ratio 1 to 8 to 27. Okay, so this is talking about areas. So first, let's get our linear scale factors. So our linear scale factors are in the ratio, this is 3 times bigger, so they're in the ratio 1 to 3 to 6. That means that the area scale factor is in the ratio 1 to 9 to 36. Because remember, when we go from linear scale factor to area scale factor, we're squaring. So if this is 3 times bigger for the length, then it's going to be 9 times bigger for the area. Okay. Now, if I know that this has an area of 1 part, and this has an area of 9, and this has an area of 36, we can now work out the missing parts. So this area would be 1. This area would be 9 take away 1. So this one would be 8, 9 take away 1, because we're taking off this part. And then this bottom area here would be, I've got 8 and 1s, I'm taking away 9. So 36 take away 9, which is where they're getting 27 from, which is 1 to 8 to 27. Absolutely, again, a really, really challenging question for that bottom one. And it's all to do with those scale factors, squaring your scale factors for that. Unbelievable. Right, question number 24. The diagram shows 8 identical regular octagons joined to enclose a shaded shape. Each octagon has side length of A. So this is A, this is A, this is A, this is A, and so on, okay? All of these sides of the octagons are A's. Find in terms of A an expression for the area of the shaded shape. Give your answer in the form P bracket 2 add root 2 a squared, where p is an integer, you must show all your working. Okay, so there's a couple of different ways of doing this. You've got a square here, which has a side length of, let's just fill in all these a's that I might need. So the length of this here is a for that bit. You've got a for that bit. And then this bit, we would need to do Pythagoras, looking at this right-angled triangle. So with this right-angled triangle, it's a, so I'm going to do a squared, add a squared, and then square root it. Okay, so 2a squared square rooted is root 2 root a squared, which is root 2a. So that's the length of that bit, root 2a. So I've got a and that. So this square is 2a add root 2a times by itself. So we're squaring that. And then we're going to add on the area of these 4 sections here. And they all have an area of a times a divided by 2. So a squared divided by 2, but I've got 4 of them. So those 4 triangles, that bit, that bit, that bit, and that bit, that is 2a squared for those. So that's fine. This is going to be my trickier bit here. So let's write that all down. 2a add root 2a all squared. Add on another 2a squared for that bit there. Okay, cool. So I now want to expand out this bracket, and I'm going to do that by writing 2a add root 2a times 2a add root 2a add 2a squared. So I've got 4a squared, add, now I've got 2 root 2a squared, and then add another 2 root 2a squared, and then add, I've got root 2 times root 2, which is 2, and a times a, which is a squared, add another 2a squared. So all together, 4a squared, and another 4a squared here, so I've got 8a squared, add 4 root 2a squared, like that. And they want it like this, so we can take the a squared outside the bracket, and we can also say that these 2 terms have 4 in common. So we can put 4 outside here, so that's going to be 2 add root 2. There we go, which is what they wanted. So therefore P is 4. Very, very, very difficult. There we go, that was it for that one. And I think that was all 80. Yeah, 5 marks for that one. P is 4. Blimey, very, very challenging questions. I think the last 3 there were very much all grade 9, and I think that should be reflected in the grade boundaries, but hopefully you found that helpful. Very, very tricky. Well done if you followed along. Let me know if you've got any questions. I'd be happy to help you further, and I hope you enjoyed it.